Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems on maximum power transfer theorem. In previous video, I have explained you what is maximum power transfer theorem, what are the different procedures that we have to follow to solve maximum power transfer theorem. Right, today we will see more problems in maximum power transfer theorem. Right, so before that I'll refresh the procedures of maximum power transfer theorem again. Right, as I said before, it is the same steps which you're going to follow for maximum power transfer theorem. That is, you have to follow the same steps of Thevenin's theorem. In Thevenin's theorem, what you will do, you will find out Thevenin's equivalent circuit, and the second step you will find out VTH. How will you find out VTH? You will remove the load resistance and you will find out the voltage across VB or AB, and similarly you need to find out the RTH value by removing the load resistance and as well as by removing the source. Removing the source in the sense, if it is voltage source, it will be short circuit, and if it is current source, it will be open circuit. And here the final step only differs. In Thevenin, you will find out IL alone, whereas here you will find out load current and as well as power. We have different formula for it, right? Here I is equal to V by R, right? That is, here it is, the R will be both RTH and as well as RL, and P is power, you can calculate into VTH square divided by 4 RTH. This is the formula, right? And we already know what is maximum power transfer theorem. According to maximum power transfer theorem, the maximum power will be delivered to the load only if RTH is equal to RL. That is the main concept, right? Now we see the problems, right? So if you see here, determine the maximum power delivered to the load. We know that in maximum power transfer theorem, you will not be given the value of RL, right? It will be just mentioned as RL alone. Now, first step, what we need to find out? We need to find out the Thevenin equivalent circuit. You know that, right? So this is the Thevenin equivalent circuit, whereas we don't know what is RL. So we will simply have at RL, and this is RTH, and this is VTH. And for finding out VTH, what we have to do? We have to remove this RL. So if you remove RL, the circuit will becomes like this. The circuit will become like this, correct? So this, it will be 10 ohm, it will be 2 ohm, it will be 5 ohm, it will be 3 ohm. It will be the same circuit, the only difference is we have removed the RA. So we have 50 ohm here. Now what we have to do, we have to find out the voltage across this particular terminal A and B, right? Which means the voltage across this 3 ohm, right? How will I find out? We can use mesh analysis, I1 and I2. And then that current will be multiplied by this so that we can able to find out the VTH. And then for RTH, what you will do? The same steps, only difference is you have to short circuit this voltage source as well. Right? In the same circuit, how will I find out? How will I find out RTH? It's the same circuit, right? Now what will happen? You have to remove the voltage source as well, right? So it will be 3 ohm, this will be 5 ohm, and now what will happen? We'll approach the circuit from this end, and now we need to simplify this resistance. So you'll find out RTH value. Once RTH value is obtained, we will be finding out, we will be solving, substituting here, right? Substituting VTH, RTH, right? And we are able to find out the IL value. What is IL value here? VTH divided by RTH plus RL. RL will be same like RTH, correct? And similarly, we need to find out power, right? The RTH plus RL, and for power, V square, that is VTH square divided by 4 into RTH, that is the formula, correct? right? So this is how we can solve this particular problem. So now I'll explain you step by step how we have solved. So you can see that determine maximum power delivered to the load, right? First we have drawn the equivalent circuit, and then I have removed the load resistance to find out VTH, and then we have obtained this particular matrix method to solve the mesh, right? And we need to find out the current only I2. Right, I already explained how to solve this particular mesh using matrix method in previous videos. Please go through it. Right, so we'll obtain I2 is equal to 2 ohm. Right, so we need to find out voltage across this particular resistor. So it is 2 into 3, 6 volt. Correct. And now we have obtained VTH. Now we need to find out RTH. For RTH, you will remove the voltage source and as well as the load resistance. Now what happens? These two will become parallel, right? And then this will be added with this the 2 ohm resistor, right? And now this becomes 5 ohm, and these two will become parallel. And if you solve, we obtain the RTH, right? And now after obtaining RTH, we know what is VTH value as well. And now we can find out the uh, load resistance. That is, you know that RTH is equal to RL. Only then the maximum power will be delivered. So whatever value you obtain as RTH, that will be equal to RL. And if you substitute those values here, we can find out the IL. What is IL? IL is equal to 6 volt divided by 1.92 plus 1.92. 1.92 plus 1.92. You can see that is the IL. And similarly, we can able to find out the power. Power is nothing but VTH square divided by 4 RTH. We substitute that 4.68. We can also calculate it this way: I square RL, right? I square RTH, right? So I square RL is same. RTH RL is same, right? So it's I square into 1.92. You will get the same calculation, right? So it is the same steps that you're going to follow for maximum power transfer as well. The only difference is at last you need to find out the power and the load current as well, right? So today what we have seen is we have seen a problem in maximum power transfer theorem, right? And we will see another problem here, which is very simple problem. Whereas here, determine the value of load resistance RL, right, when it is dissipating maximum power. So by using maximum power transfer theorem, right? So for maximum power transfer theorem, you can find out first step, you need to draw the equivalent circuit, correct? So you draw the equivalent circuit. This will be RL, this will be 6 ohm, this will be RL, right? Sorry, this will be RTH, this will be RTH, and this is VTH, correct? And now we need to find out the VTH. How will you find out VTH? Now you remove this load resistance. What will happen? You will have only 4 in these two resistance, right? So I is equal to V by R. So it is 4 divided by 8. So it will be 0.5. So we have to find out the voltage across this particular terminal, right? So it will be 0.5 into 2, it will be 1 volt. That is VTH. So for RTH, what you will do, you have to remove from this circuit, you have to remove the voltage source, and as soon as we have to remove the load resistance, correct? Right, now if you see this particular circuit, you have to approach from this end. So this will be 6 ohm, this will be 2 ohm. Now these two becomes parallel. So if you solve parallel connection, 6 into 2 divided by 6 plus 2, right? So you'll get 1.5 ohm. So now we obtain what is VTH and what is RTH value. RTH value is same as the RL value, right? And now substitute this formula, power max VTH divided by 4 RTH, you will obtain the power. And even if you find out the IL value is nothing but VTH divided by RTH plus RL. We can able to find out, right? We can also find power in such a way that I square into RL, right? So it is the same steps. So if you follow the steps correctly, then you will obtain the answer easily, right? So today we have seen problems on maximum power transfer theorem. I believe this video will be very useful for you. Thank you, my dear students.